Welcome to solverfy.
In this question, we're taught about lead carbonate. Right? It's one of the components that passivate layers that form inside lead pipe. So here, we're told that if the Ksp of lead carbonate is 7.4 times 10 to the power minus 14, that what is the molarity of lead in a saturated solution of lead 2 carbonate? So if you have lead carbonate, it should dissociate to produce Pb2 plus aqueous plus CO3 2 minus aqueous. Right. So Ksp would be equals to Pb2 plus aqueous concentration multiplied by CO3 2 minus aqueous concentration. And this is 7.4 times 10 to the power minus 14 is equals to. So the concentration of the Pb2 plus and the CO3 2 minus, they are the same. So we can assume that the concentration of CO3 2 minus is equal to the concentration of Pb2 plus. So that will give us Pb2 plus aqueous square, because we say Pb2 plus aqueous is equals to CO3 2 minus aqueous. Okay, so the Pb2 plus concentration will be equals to the square root of 7.4 times 10 to the power minus 14. So that will be 2.72 times 10 to the power minus 7 molar. So B said, what is the concentration in parts per billion ions in the saturated solution? So we need to convert the 2.72 times 10 to the power minus 7 molar to parts per billion. So parts per billion is micrograms per liter. So to do this, we need to find the molar mass of lead carbonate, and that will be um, that will be 267 0.21 gram per mole. So we calculated the concentration to be 2.72 times 10 to the power minus 7. So 2.72 times 10 to the power minus 7 molar or mole per liter. And molar mass of PbCO3 is 267.21 grams per mole. So if we multiply the two, we'll get the concentration in grams per liter. So that'll be 2 times 267.21. So that'll be 7.27 times 10 raised to the power minus 5 grams per liter. So we can convert this to milligram. So we know 1000 milligram is equals to 1 gram. Therefore, multiply this by 1000. So we're going to have a 0.0727 milligram per liter. Then we convert this to micrograms. So 1000 microgram is equals to 1 milligram. So multiply that by 1000 again. So this would be 72.7 microgram per liter, which is equivalent to 72.7 parts per billion. So the EPA threshold So the next question said, will the solubility of PbCO3 increase or decrease as the pH is lowered? So lowering pH means acidic condition, okay? And that is H plus. So if we go back to the equation that we write for the dissociation of the PbCO3, we have Pb2 plus aqueous plus CO3 2 minus. So if we make the condition acidic by lowering pH, the CO3 2 minus will react with the H plus to produce H2CO3. So this will increase the solubility of PbCO3. So that will increase solubility. This said the EPA threshold for acceptable level of lead is 15 parts per billion. The saturated solution of lead 2 carbonate produce a solution that exceeds the EPA level? Yeah, it does. So the answer is yes. Because we calculated it that to be 72.7, so that's above the EPA level. Just check something to be sure. 2.72 times 10 raised to the power minus 7. Oh, so we should be multiplying by the molar mass of lead here, not lead carbonate. Since we calculated the molar mass, we calculated the concentration of lead here, so we should be multiplying by molar mass of lead, of atomic mass of lead, which is 207.2. Okay, so this is 207.2, and this will give us 5.64. This is 0.0564, and this would be 56.4, and this should be 56.4 parts per billion. And of course, the subsequent answers stay the same. Yes, everything remains the same.